All right, guys. So as we have been looking at from the previous class, we have been looking at solutions to triangles, and we started off by looking at the general standard notation for triangles and how they are labeled. Triangles are labeled in special ways where the sides meet to form a point. We call that a vertex. We label those vertex are vertices plural with capital letters. And the side which is opposite to that vertex or which is facing the angle of that vertex is called opposite to that angle. And so we label the opposite sides with a common letter of their vertices. All right. So all of these are things that we have gone through already. So we're just quickly recapping and then we are continuing. So we talk about right angle triangle. And we know that right angle triangle is a special kind of triangle with special properties. We say that we have a 90-degree angle, which is represented by that little square in the corner box here. We label the right angle triangle in the same way as how we label any normal triangle. So the vertices are labeled with capital letters. The sides opposite to those vertices are labeled with common letters to the vertices. All right, so basically for a right angle triangle, we describe the longest side as being as the hypotenuse, and the angle with the 90 degrees would be opposite to the hypotenuse, or the hypotenuse would be opposite to that 90-degree angle. So always the hypotenuse is opposite to the 90 degrees angle. Now you can look for this little box in the corner, which is an indication of a 90-degree angle. And once you find this box, then clearly you should be able to find the hypotenuse by looking right across from that 90-degree angle. All right, so we say that the other two sides of the right angle triangle may be referred to as opposite or adjacent, depending on which of the non-90-degree angle you're referring to. So we know that the angle B is 90 degree. So based on the properties of triangles, we know that all the angles within a triangle must add up to give you 180 degrees, 180 degrees. So the other two angles, A and C in this case, those two angles would add together to give you 90, because B is already 90. And when you add those two angles to give you 90, so you get 90 plus 90, the total angle in the triangle is going to be 180 degrees. All right, now opposite, as you already know, so the side BC is opposite to the angle A, and that side is labeled with common A as the vertex. The side AB is opposite to the angle C, and it is labeled C, which is the common letter to that vertex that it is opposite to. So that's what we refer to as opposite. Now, in terms of adjacent, if a side is not in front of the opening of an angle, then it may be alongside the angle. But one other thing that I want you to notice too, sometimes it can be confused that the hypotenuse is adjacent because the hypotenuse is also alongside and these angles. But if you identify the hypotenuse from early, then you should not confuse the hypotenuse with what we refer to as adjacent. So any other side apart from the hypotenuse that is alongside an angle is adjacent to that angle. So in this case, the side A is alongside the angle C, and so we refer to A as being adjacent to the angle C. The side AB, which has a side C, this side C is adjacent to the angle A, in that the side is alongside the angle A. And so we say that C is adjacent to angle A. And so that's how we identify what we refer to as opposite and what we refer to as adjacent. And as you go along with triangles, we'll be working with quite a few right angle triangles. And after we have gone through Pythagoras Theorem, we'll be jumping into some trigonometric ratios, which also apply to right angle triangles. So one of the things that we have to pay attention to is how to identify the sides. How do we know when a side is opposite to an angle? How do we know when it is adjacent to an angle? And the longest side should not be difficult to identify, because that side would be the hypotenuse, and it is always opposite to the 90-degree angle. All right, moving along. So this is a picture of the great Pythagoras Theorem. As you can see, he looks like a Greek personality. So he was from those Greek periods. So Pythagoras was an ancient Greek philosopher and mathematician. He is best known for the Pythagorean theorem, which states that the sum of the squares of the sides of a right angle is equal to the square of the hypotenuse. So in essence, we're referring to the sum of the square of the opposite and adjacent would be equal to the square of the hypotenuse. And so in the worded form, the hypotenuse squared is equal to opposite squared plus adjacent squared. Oftentimes may be written in a formula looking like the one below, which is a squared equal b squared plus c squared. Now, as I mentioned before, this formula is not necessarily beginning with a at all times. So in order to determine which side you're starting with, you have to look at your triangle, identify the hypotenuse, and whatever side that is should start the theorem. So that would be, hypotenuse would be on the left-hand side of the equation, and you should square it. And the other two sides, you should square them and sum them on the right side of the equation. And that's what the theorem really states. All right, we had gone through this example already. We saw that we were given worded questions and we were to construct our triangle and label them. And so based on what is given in terms of angles, if you have a 90 degree, you look for that 90-degree position in the triangle, which is somewhat easy to identify because it generally is the point where two sides forms a L. All right, and then once you put in the 90-degree angle, then clearly now you can choose any of the other angles to represent the unknown angles. And you can also represent the sides in relation to these angles. All right, so using Pythagoras Theorem, all that we need to do, identify the side, which is the hypotenuse. In this case, it's B. And it so happens that we want to find a value for B. And for Pythagoras Theorem, when do we use Pythagoras Theorem? Anytime we are given two sides of a right angle triangle and we want to find another side. Because you have three sides to a triangle. So if you are given two sides to the right angle triangle, you can always apply Pythagoras Theorem to find the unknown side, right? All you have to do, write out the theorem first in the correct order, substitute your values where they are positioned in the theorem, do your calculation, calculate the unknown value. And after you calculate the unknown value, then whatever value that gives you will be the value for the unknown side. So I want you to just understand, you don't need to know any angle to work with Pythagoras Theorem. You only need to know that the triangle is a right angle triangle in which you have a clear 90 degrees angle. All right, guys? All right, this was The second question was asking you to do the same thing. Now, instead of the side which is unknown, instead of the hypotenuse being the unknown side, this time, the side which is unknown would be the side opposite to the angle C. Now, because it is an opposite side, it's going to be on the right side of the equation. So C squared is on the right side of the equation. A squared is on the left side because A would be the hypotenuse. Now, B squared and C squared would be on the right side. Now, we don't know the value for C, but we know the value for A and we know the value for B. We can substitute those values where they are in the equation and square them. And then we do our calculation for the unknown side C. Now, it might mean that you may have to rearrange the equation if you're trying to find one that's on the right-hand side. So it means that in this case, because we want to find C, we can rearrange the equation. Move what is beside C to the other side and change the sign. Now, I mentioned that if you move this B squared to the left-hand side, you'll get A squared minus B squared. But then you could also flip around the equation after you do that. And so once you flip it around, then you will have C squared on the left-hand side and then A squared minus B squared on the right-hand side. Is that clear to everyone? Any questions so far?
Sir, I understand what to do, but I don't understand why. Could you repeat why, like how you make C the subject? I know that C is supposed to be the subject, but how did you make the subject?
All right. Now, in making the subject of a formula, there's a whole topic on that. Unfortunately, we have not reached that topic yet. But one of the basic ways of making C the subject in this case, you want to keep C by itself on one side. So anything that surrounds the C, you want to get them to the other side. Now, if the value that surrounds the C is a positive value and it is added to the C. So wherever you have addition and subtraction in terms of the terms, you just note what sign they have. And once you see the sign, you move it across to the other side and then change the sign. So the B squared would be positive on the right-hand side. You move it across and change the sign. Now, the A on this side is positive. So it means that if you put the B out here, you're going to have minus B squared plus A squared. But it's a little awkward to write your equation starting with the negative. So what you may want to do instead of doing that is write the A first, since the A is positive, and then write the minus B. So you would have A squared minus B squared. Now, what remains on this side will only be positive C. Is that clear to you so far, Mr. Lamar?
Yes, sir.
All right. So now, because we generally want to keep our subject on the left-hand side of our equation, because it is the way that we practice to do it. Not that we can't work it on the right-hand side. We could solve it with the subject on the right-hand side. And when we talk about subject, we really mean whatever you're solving for, that will be the subject, and the subject is always by itself on one side of the equation. All right, so because we want to keep our subject on the left-hand side, we can just flip around the equation. Put the C squared on the left and the A minus B on the right. We're not changing any sign here. Once you're doing a flip, you're not changing any signs. It's like thinking of the equation on a rotating axis, and you rotate the right side to the left and the left side to the right. Is that clear, guys? So you don't change the sign, you keep the sign exactly as they are before you rotate it. All right, so that is how we get our equation now to look like this. And why we do this arrangement is the fact that the side that we're trying to find is not the hypotenuse. Is that clear to you, Mr. Lamar? So that's the only time when you do the flipping around. When the side you're trying to find is not the hypotenuse, that will generally cause you to move or make that side the subject. So whichever side which is not the hypotenuse, it will have to become the subject. But the formula always starts out with the hypotenuse of the subject. So you have to write it in that form first, where the hypotenuse is the subject, and then from there, you do the rearrangement. Is that clear?
Yes, sir.
Okay,
yes,
good.
Sir.
All right, so with all of that said, if we do if we transpose the formula and make the subject, all that we need to do afterwards is just plug in the values that we are working with. So we don't know the value of C, we know the value of A, we know the value of B, we plug those in, keep the square sign. Next, what we do is square the values that we have. So we square 6.4, we square 5.2, and we get that. And then we subtract. Remember now we are following the bedmass rule. You work out power first before you do subtraction or addition. All right, so now you can subtract 27.04 from 40.96, and that will give you 13.92. Now to get rid of your square root, there's two ways you can think of this now. Just imagine that you bring this square over here and it turns into a square root. So you can think of it that way. So if you're thinking of it that way, the square above the C, we can now write C equals to the square root of 13.92. And then now we just use our calculator to work out what the square root of that number is. And that will give you the answer to C. Now, even though we are loosely using the square root to give you a positive value, when you're finding the square root, you have also a negative value, but we're not going to be focusing on the negative values, because once we are working with real world length, any length in the real world, not an imaginary length, a real length, it cannot take a negative value. So that's why we keep our answer as a positive value. But square roots generally give a positive and a negative value. All right, guys. So here, when we find the square root of 13.92, we get 3.731. Now, this answer gives you 3 decimal places, but our question that we have been working with, the numbers are rounded off to 1 decimal place. So to make your answer compatible with what you are working with in the question, you have to round off your answer to the same number of decimal places that your question have. So if you round off 3.731, what we want is to round it off to 1 decimal place. So we look for 1 number after the point. If we were rounding off to 2 decimal places, we look for 2 numbers after the point. Now in this case, we have 1 number after the point, and that's where we want to round our value. So after we identify that number after the point, we examine the number that follows that number that you're rounding after. You look at the number that follows. If this number is less than 5, you're going to write your answer to the decimal place and drop drop the number that is less than 5 and any number that follows it. Once this number is less than 5, we drop it and then keep the value with the 1 decimal point being 3.7 centimeters. Now, if for argument's sake, that the value that follows the 7 was a number greater than 5 or equal to 5, then in this case, we would have to add 1 to the 7 and drop the remaining numbers that follow. And then it would become 38 instead of, 3.8 instead of 3.7. So I hope you guys remember how to do rounding off. All right, is that clear, guys? All right, so now we still want to do a little practice on these. So these are 2 questions that we have here. I'm just going to work through the process so I can become more familiar with the procedure. So on the left side, we are trying to find the unknown value. And in this case, the unknown value is x. Now, what we also want to do is identify what side x is. So we want to know if x is a hypotenuse, if it's an adjacent or an opposite side. Now, what can we say about the side x for the left triangle? What side it represents?
So x represents the hypotenuse.
The hypotenuse. So once you identify the side of your hypotenuse, you write your Pythagoras Theorem formula starting with that side. So what we know, we're going to have x squared. Writing out the formula. Anybody remember what the formula is?
X squared.
X squared. And now we can just put in these values. So x squared is equal to 5 squared.
X squared plus 12 squared.
12 squared. And it doesn't matter which one of them come before. So you could start off with 12 squared and end with 5 squared. It doesn't matter in that sense. Once you're working with the opposite and adjacent side on the right-hand side, it doesn't matter the order in which they appear. All right, so once you have done that, then you would go through the process of now squaring the numbers. Now the x is the unknown, so clearly we're going to leave the square above the unknown. So we have x squared on the left side. On the right side, we can square 5. If you square 5, what do you get?
25.
25. All right, guys. There's a wrapping up signal for the Zoom in the next 10 minutes, guys. So if you see cut off, you know what to do. All right. So we have 25 because when you square 5, you get 25. Plus, you square 12, you get what?
144.
144. Now when you add them, what you get?
169.
All right, so x squared then would be equal to 169. Now you don't have to use your units in your calculation, but in your answer, you have to put in your units. So you know your units would be in centimeters. So we put 169, and then next, what we do, we try to find the value of x. And as I say, just imagine that you're moving a 2 from the power and it's going to transform into a square root on the other side. So here we're going to have x is equal to square root of 169. And the square root of 169 would give you what?
13.
13. And so we would get 13, and now we put in our units, which is 13 centimeters. All right. Now, if we look at the the triangle on the right, what we want now, we want x, but if you notice this x here is not in the position of the hypotenuse, but instead it is either the opposite or adjacent to one of these angles, these other non-right angle. All right, so here we have to identify which side is the hypotenuse.
12 centimeters.
Right, so the 12 centimeters on the hypotenuse side of the hypotenuse. So we start off the equation with that. So 12 squared is equal to x squared plus 5 squared. So once you have the other two sides, they're going to be on the right side of the equation. All right, now you can rearrange the equation from here if you find that easier for you. So if we rearrange this equation, we want to keep x by itself on one side. So if we keep the x by itself on the right-hand side, then this 5 squared has to go to the left-hand side. So that would give us 12 squared minus 12 squared minus 5 squared. And by now, I would imagine that everybody knows why the sign is changed to a minus. All right, so we are going to now equate that to x squared. So we have x squared on the right-hand side. All right, now, as I said, you could actually do the calculation and keep x on the right-hand side if you want. You can do that, all right? And if you do that, you would work out your numbers on the left side. So square 12, you get 144. You square 5, you get, square 5, you get what?
25.
25. And that now going to be equal to x squared. Now, if you take away 25 from 144, what you get?
119.
All right, so you would get 119. Is it 119? Yeah, 14, yeah. So it's 119 equal to x squared. All right. Now, you could always now flip around the equation. So you could put the x squared on the left-hand side. And then now you put the 119 on the right-hand side. Then now, you will now just bring this to across and change it to a square root. And so this right-hand side is going to be the square root of 119. And if you use your calculator, what value you get for that? Anybody?
Square to one, this square to a whole number, it would be 11.
So to a whole number, it would be 11 centimeters. All right, now I forget was to remind you that for those of you who don't have a scientific calculator, you're going to need one for this topic. So if you need to borrow one, I don't know how much you can afford, but if you can borrow one, or better yet, buy one, then you will be able to participate in this calculation, because trigonometry will require your calculator to do this calculation. So try to have a scientific calculator by the next class. All right, guys? Is that clear?
Yes, sir.
Yes, sir.
All right. All right, so everybody's okay with these two examples here, these examples? Guys, raise your hand if you're comfortable with the two examples. Dorothy, Miss Green, Miss Brown, Mr. Lamar. Anybody else? All right, so with that said, guys, we're going to get some practice now. So I'm going to give you some questions to try. So we have two sets of questions. So we're going to do this one first, and then we move on to the next. All right, guys. So as soon as you finish working out the value for X for these right angle triangle, then we will walk through them together. All right, guys. So you have about 10 minutes to work these 6 triangles. You maybe don't need so much, but I'll give you 10 minutes. Bear in mind, guys, that the Zoom might run out soon. So just log back in if the Zoom cuts off.